In this episode of the Cisco Tech Stories podcast, we open the history books.
Those protocols were developed in the previous century.
And we also look into the future.
They will lose some features and there will be panic.
Stay tuned for episode 31 of the Cisco Tech Stories podcast.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Welcome to this new episode of the Cisco Tech Stories podcast. In this episode, we shine a light on the often overlooked risk in cybersecurity, the network infrastructure. While servers and endpoints are usually protected with the latest security tools and updates, network devices themselves can be left behind.
Yes, we'll also discuss the latest efforts to make network infrastructure more resilient, including removing unsafe features, adopting stronger authentication, etc. So stay tuned for actual insight about how adversaries might get into your network and practical advices and resources to help you reduce the attack surface and protect your organization network backbone.
So once in a while, we interview ourselves, and that's what I want to do today. Last time I interviewed you on this podcast was when you were in TAC and working on a service provider cable problem, which was, I think, one of the most fun episodes we had. But now I think you're a security researcher, right? You work on security vulnerabilities?
Yeah, I work on that, but not just that. So what if I told you that there are ways of getting inside the network, large networks, without exploiting any vulnerability at all?
Yeah, like social engineering, right? That's one of them.
Social engineering is one of them, but there are a lot of different ways. And that's really what I wanted to talk about today. When there are vulnerabilities, that's easy. We identify them, we fix them, we publish an update, customer upgrade, they are safe. But yes. When there are no vulnerabilities, what do? We cannot fix anything if there are no vulnerabilities being used, right? And that's what we will discuss about in this episode, right? So coming back to the initial point, what if I tell you that there are ways of getting in the network without exploiting any vulnerabilities? That's what we call living off the land. Living off the land means, okay, use what's there. Take a step back and look at a company network, a large customer, a large infrastructure. Servers and computers, like company-provided computers, have been having security software on them for years, like what we call EDR, endpoint detection and response. So EDR software, that's the thing that will detect whether your computer is acting a bit weird and contacting IP addresses that should not, and things like that. So that type of software has been on your company computer for years. You also get antivirus and constant updates.
Right. So antivirus is pretty much a thing of the past, right? Like you would get a virus and then people say, yeah, don't click on anything. But then you have phishing emails and you may receive a virus without really knowing it and thinking it's a business email. So you have all the process part where you have to train your employees not to click on whatever, etc. But then antivirus software has really evolved into smarter stuff. I've seen zero trust applications, stuff that doesn't just check for malicious behaviors, but really look, are you allowed to do this? Are you allowed to do that? Right. So it's more like behavior analysis of the laptop, and there's various techniques and stuff, right?
Yeah, exactly. So the virus thing is really when you have a piece of code that runs on your computer and does things that it's not supposed to do. But then the EDR part is more like behavioral. So look at which things are being run on your computer and which services you connect to and things like that. So a bit outside of the process themselves, but more on how it's behaving, right? But the thing is, that's on servers and computers. What about network devices? Network devices are, for good or for worse, mostly transparent and invisible to the people, you and me, for instance. When we talk over this connection here, there are probably tens of switches and routers in between, and we don't see them. We just assume that they are there and they are doing their work, right? The fact that it's invisible means that they have been a little bit forgotten from some of those enhancements, let's say. It's become a risk and a focus point for threat actors. So threat actors migrated from exploiting servers and computers as their entry point to the network to network devices. This is where the living off the land thing is. It's basically using what's there. There was a report showing that over half or close to half of the network infrastructure that's used in companies worldwide is obsolete, outdated or end of support or close to end of support. And that brings a problem. It's a lot of old code that contains potentially legacy and unsafe configuration.
We always beg people not to use default passwords. And actually now Cisco devices prevent you to leave the default password. A lot of them should just push you to change it, etc.
There shouldn't be a thing called default password. That should not exist. Yes, default password, but also default configuration that's unsafe. For years, many network devices had Telnet enabled or HTTP server instead of HTTPS server. If left open by default, are potential entry doors for threat actors. For instance, you would be surprised by how many devices we see that have weak SNMP communities, like company name 123, right?
Or even private, simply private.
Or private, public, or variation of dictionary words, right?
Yes.
You might think, I'm not exposing SNMP to the outside world. It's protected by an access list. It's only available in my internal network. Sure, but something that people don't always realize that SNMP spoofing is a thing. Because SNMP is UDP, you can spoof your IP address as a sender and put an IP address that would be allowed by the access list. For instance, a private IP range like 192.168, blah, 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 has a very high percentage of being accepted by your access list. And if not 192.168, it's going to be a 10.0 or 172. Something. And you could craft an SNMP packet from an IP address that would be likely to be accepted by the access list and try several SNMP community, company name 123, public, private, a lot of dictionary words and things like that. And you might get lucky. Right? That's not the secret. SNMP spoofing has been known for years, yet SNMP is still widely used. The moment you get a hit, and it's not if you get a hit, it's when you get a hit. Depends on how much effort you put into trying to break that, you will eventually get onto one device.
But it's not even that hard, right? Because, I mean, I think security people think about a lot of defensive layers, right? So they say, oh yes, we use SNMP, but we don't have the default community. But plot twist, it's Cisco 123 or whatever. And then they say, yes, but we also do a source IP verification check. Like you said, a lot of devices say only accept SNMP from this IP. But we know that typically it's not just one IP. People, not out of laziness, but for practical reasons, say, well, let me put my management subnet, right? And management subnet is always going to be 10 dot whatever. So it's like, oh yeah, it's one more security. And then maybe firewalling would prevent normally to send SNMP packets from untrusted regions of the internet or whatever. And people think, oh yeah, but I'm safe. But I think now a lot of people have malware packages, right? That is going to automate all of that and brute force all the main passwords. It's going to try SNMP with all the typical community names. It's going to try to change the source. All of that is done automatically. And with the firepower we have now with cloud services or whatever, botnets or whatever, it's really not hard at all to brute force and try the most classical stuff, right? For a good server, it's probably a few minutes or whatever to guess. And then once you have that, you have management access, basically, right?
Yeah, and you only need the tiniest of tiniest door to get into one device. And once you are inside one device, it's quite easy to expand to a lot more. SNMP spoofing being one of them, HTTP server being exposed with default credentials is another one. It's a typical forgotten device, this thing that you had a device that's not used for like 10 years and still has software and configuration from 10 years ago. It's probably not connected to anything except your management network. And that's a device that's waiting to be compromised. And you might say, sure, but it's not connected to anything, so who cares, right? And once you're on one device, you can learn a lot of things. Just look at the configuration of that device. What will you see on that configuration? You will probably see, SNMP community, but you knew it because you probably accessed through there. Mm-hmm. You will see local users. At least the username will be in clear. The password, depending on how it is configured, might be type 7, Cisco type 7 password, which are reversible.
Sometimes still in clear text. I see it, yes.
Yeah. You should not do that. You should also not use type 7. But we still see that being widely used. And once you know like an admin user credential, like a local user, how often do you think that local users are changed between devices? I mean, if you get one, it's likely that it's going to be the same on any other device from that company. So you just need to get one and you probably get access to a lot of devices. if you look at the configuration, you will see like interface descriptions, right? And interface description might tell you, okay, this is the interface to my Redis server or interface to my core network. So that gives you a hint from, if you are a threat actor and you look at the config, these are the interface that I might try to capture traffic on, even if it's a legacy device that's not connected to anything anymore. What are the chances that monitoring software is still polling it periodically, either by SNMP, by telemetry, or an SSH server that will connect to that device and run, I don't know, show IP route or whatever.
And syslog server as well, because syslogs are sent in clear text, and there's typically an IP where you send the syslogs, and then that syslog server is receiving all the message from all the network device.
That's true, that as well. If you come back to the previous example where you will have monitoring systems that will connect periodically to this device, they will often use, like I said, SSH. And they will use probably another user than the local one. Maybe it's going to be a monitoring user. And it might not be configured locally. It might be configured through TechAxe. But you are on the device. You have access to tools like monitor capture, allowing you to do a PCAP, and you can monitor the TechAxe traffic. You're going to say TechAxe is encrypted. Yes, but it's encrypted using a local key that's configured on the device itself. So you have the key, you have the encrypted traffic, it takes a minute to decrypt it, and you get the credentials of anyone actually who connects to that device. You can harvest more credentials. And with that, spread in the network, gain more foothold onto different devices that were not exposed directly through the internet, unlike that first device that you came through. You went from one device to multiple devices, still using no vulnerability, just by using what's there, living off the land. And from there, you will try to establish persistence. So getting a way to stay in the network without having to use the first door that helped you getting in. And how can you do that? Our devices allow you to run standard Linux binaries, for example, through guest shell. So guest shell, for those who don't know, is a method to get like a Linux shell, contain shell inside the device and let customer run their own applications. But if it's not controlled correctly, it also can also let threat actor run their own SSH server, for instance, on the port that's not 22, but something much higher, something that is not protected by access list, and create a custom user and get you back onto that device directly. That gives you a second foothold in the network, and one that a network engineer from that company would not expect, because if you create an SSH server that listens on a very high port on a device that you didn't expect to have any services to be online, to be reachable online, most likely that network engineer will not even check that device. They will check probably the initial entry door, and they will probably close that door. But since you as a threat actor open the second one, you can close the first one, threat actor can still come back. And now if you repeat that to every single device that you touch, you have a lot of doors to come back. And from there, so rinse and repeat, basically. So repeat the same thing over and over.
So basically you need one device in the network to be a bit too old, or with some default password or some configuration that is not super secure. And once you have that, you can get access to other network devices, which are maybe new, maybe more secure.
Exactly.
They are properly protected, but you gained access from another device, which in its config had details about the more secure network device, right? So you're just as weak as your weakest point in the network.
And that's unfair battle against threat actors, if you want, because for your company network to be secure, you need to be sure you close every single one of those doors. And if you talk about a network that's several thousands of devices large, it's a lot of things to check, while on the threat actor side, you only need one tiny door to get in. So you see the unfairness there. Once you're in, it's easy to learn more.
And we all know the difficulty. There's always that guy plugging something in a network that you're not aware of. There's always, but we cannot get rid of that box because it's used for some very old stuff that we still need and whatever. We know this one is end of sale, but we still, need it in the network and it doesn't support this or that. It's always going to happen.
Yeah, unfortunately. This is why being aware of those tactics is important. This is why we have actually a lot of what I'm telling you here documented, so that you can find it and read exactly what actual threat actors are doing, and make sure that you close those doors. So one of the things that we will talk about what Cisco is doing to prevent this from happening, right? But one of the things that we are doing is publishing hardening guides for every single Cisco platform on things that you should check and things that you should disable or change as configuration if you're a customer and want to make sure that your attack surface is reduced for the threat actors. So check those guides, but we will be doing more, and that's what we will talk in the second part of this show. So this is what we will do as Cisco to make sure that we remove everything that is unsafe, insecure, legacy, obsolete. And to finish on what I was mentioning, so once you're in the network, you're gathering data. One of the things that we will see threat actors doing is exfiltrating data. One of the common ways of doing that is just by creating a GRE tunnel, like your own VPN tunnel, to an infrastructure a threat actor controlled. Establish that tunnel and send whatever you want. It's going to be encrypted. They can use an IP address that doesn't look too strange, for example, from the same country as the environment that you are attacking, and exfiltrate that data. You can be there for years before you get noticed. It's much harder than you think to identify these type of activities, because not only those are legit features from the device. So if you read through the configuration of a box and you see a GRE tunnel amongst hundreds of other GRE tunnels, it's very hard to pinpoint that this one is illegitimate compared to the others. Also, you will see the configuration changes being done by legit users, because remember that they harvested credentials. Yeah. Exactly. They harvested credentials of legit users, so they just use that. And if you see the real admin IT infrastructure doing a network change, you say, okay, probably expect it, so that's fine. You might also see the threat actor clearing the logging, disabling the logging to hide things that are a bit suspicious, so it makes it a bit hard from the IT perspective and the forensics perspective to know what's been done. I mean, if we disable totally the logging, you have no data to analyze on. That gives those threat actors a lot of ways to do bad things in the network.
Where do we go from there? What do we do about it?
What do we do from there? So, as I mentioned before, if it was a vulnerability to fix, we would fix it, right? The problem here is that nothing that's used here is a vulnerability in itself. This is just a combination of insecure, legacy, and old stuff that's still there for backwards compatibility, for convenience, and we think it's time for that to end. So we will be actually removing a lot of stuff from devices in the coming years. And we will do that across the board. So not just on iOS, not just on XR, not just on NXOS, it will be everywhere. And we will remove a lot of stuff. And this is also why we wanted to have this talk, this podcast, so that we can let people know that things will get removed from network devices, mostly unsafe legacy protocols. We will also disable things that were enabled by default, and we will do that across the board and in several phases. So first, if you are using a unsafe feature or something legacy that will get removed, there will be a warning being displayed, right? So you'll know that, okay, this configuration is unsafe and should be removed. It's not going to be removed immediately, right? We want to give you the chance of updating the configuration, having a safe way out of it instead of breaking your network by just removing things right away. There will be first a warning.
People don't like that somehow. I don't know why.
Yeah. It's going to be a change, and it's going to require some work from our customers. So it's for a good reason. People should not be using Telnet today. People should not be using TFTP today. HTTP, not HTTPS, and other features like this. These should not be in use anymore. That will eventually go. So after the warning phase, there will be a phase where the feature will still be there, but it will require you to do a lot of things to enable it. We want to make it hard to enable those unsafe features. We want to make sure that you know that this is unsafe. A warning, you could miss it, right? But if you have to go through 5 hoops to enable a feature that's unsafe, you will probably know that it's unsafe and you should find an easier workaround that would be using a safe replacement, for instance, SSH instead of Telnet and stuff like that. And eventually, those features will get removed. So in the last phase of this project, those features will get removed. After that, no way of enabling Telnet anymore. And hopefully, whatever is left will be using a more secure version of what was removed.
Every time there's a replacement, right? Like at Telnet, you have SSH, and even SSH, we're bumping up the ciphers and only using the latest SSH versions.
That's correct.
I saw syslog, and I was like, but how do you log then if you don't have syslog? Well, there is secure syslog, right? So the point is not to have your syslog messages, which are typically very critical because they mention usernames and stuff, to not have them in clear text. So there's always a solution for each of the feature, right?
We are removing, deprecating only things that have a secure replacement. For instance, I mentioned that HTTP will get removed. Yes, but there are some features for which HTTP is mandatory by specification. Those will stay, right? But there are a lot of others that have a secure replacement for years, and the example being Telnet and SSH. There is no good reason today to have Telnet enabled, right? And that will go. And if you go on the Resilient Infrastructure website, we will have the link in the description somewhere, you will see the list of those features. And there is a PDF document that will describe what the alternative is and in which version for each platform these features will get removed. So I encourage you to look at that document and check it periodically just to see where you are compared to that document in your network infrastructure, so that we make sure that we reduce the attack surface for those threat actors as much as we can. And eventually you will be in a better posture compared to before.
So the fear is that people, first of all, people don't always upgrade to the very latest iOS release, right? But then one day they will upgrade, and then they will lose some features, and they will be panic. And the way we're tackling this is by giving a lot of warnings before that happens. So
yeah,
I think the key takeaway for people is just that they should read those messages and slowly think about migrating their config, right? For some stuff, it should be a no-brainer, like Telnet, you don't really need it, right? Some stuff you may need, we only have a syslog server that supports regular syslog, not secure, so we need to move to a syslog server that supports secure syslog. So you might need to do some steps for some of the items, but you have the time to do that. And actually it's for your own good, right? Like you should have been doing that in the past 10 years already, if not more. So it's about time, right? Like I don't think we should complain about it.
Yeah, indeed. And like I mentioned initially, this is really coming from learning what we have seen from threat actors. They were really using those unsafe defaults, unsafe features to get into the network. And I don't think it would be responsible for Cisco to say, yeah, but that's your own fault if it's there. I think it's time. Those protocols were developed in the previous century, most of them, like Telnet, TFTP, and things like that. They were developed in a time where internet was either not a thing at all or very different from what it is today. In the 1990s, 1980s, cybersecurity was not really a thing, and we did not think that threat actors connecting to devices through the network would be a thing, probably. So we didn't think about security at that time, and that was okay for the time. But now that we know what threat actor can be doing with this, it is really time to close those doors and make sure that secure versions of those protocols are in use. And I mentioned that we will remove features, but we will also add a few things. One of the things we will add is post-quantum crypto, but we also add things like logging and monitoring in places where there wasn't logging and monitoring or not enough. For instance, inside the guest shell and the underlying operating system. The reason is, in the past, when you were connecting inside the guest shell, you would not really see what activity was done inside the guest shell. That's a problem. Right, you want to know what people are doing inside the guest shell. Yeah, so we will be adding logging there, as well as in the underlying operating system. We will be adding TACACS over TLS. We will be adding public key authentication via TACACS, so that you can log in with your SSH public key and have TACACS handle that for you instead of having it locally configured, so that you have a central place to verify authentication. And we'll be adding some more stuff. So we will be removing a lot of insecure things, but also adding some more that help you have better visibility inside your network and help you scale some of those secure protocols a bit better as well. So hopefully all that combined will make it much harder to get inside your network.
Even if you're not really, into best practices and not doing a lot of effort to secure your network, the default will be already a lot more secure than it is now, right? We're not going to let you do crazy stuff anymore.
We want things to have what we call secure by default. And if you need to enable a feature, it will be enabled with default values that are secure.
And it's like the post-quantum crypto. You should not wait. It's still debatable when the quantum computers will be able to break cryptography. But as we saw with Fred and Tim as well, We should not wait for that to happen, because we already have crypto now that is most likely resilient to it. And so if you wait, oh, damn, we have now, some threat actors have a quantum computer that can break. The time you start changing your certificates, your keys everywhere, it's going to be too late. And already with the store and decrypt later now is a good time to start moving slowly, right? So, try post-quantum crypto on your most critical services, see how it goes. Start migrating, because we know it takes time. So how about you start now, right? That's the spirit.
Yeah, exactly. It's like the analogy is like when you take the plane, you should read the safety card before you take off, and not when the plane is in the ocean already. So
it's a small card. It's not too bad. It's just a few instructions, easy. There's worse.
And actually, the resilient infrastructure project here is basically the same thing. It looks like a lot, but I doubt that you are having all the unsecure values in your network. You probably have one or two unsecure protocols, and that's it. Not all of them. Read those documents, and you will see that probably it sounds like a lot, but what is really configured in your network is not that bad, and you can phase those changes in your network to have it in a reasonable timeline, and eventually getting you safe in not such a long time.
And I think there's a lot of activities on the Cisco side about this, right? It's not resilient infrastructure is one of them. I know with iOS 27, so the one coming next year, we have a completely new operating system under the hood. So again, should be transparent. It doesn't bring very visible features, but from a security standpoint, it's a huge improvement. And we're going to come with features that we're able to proactively lock. Even without vulnerability, we can lock when the threat actor is trying to do something that is not authorized. So it's a lot more permission-based. It's a lot more in the zero trust spirit, that you can't do crazy stuff on the network device. So there's a lot of stuff under the hood. Probably we'll try to do another episode on that, right? But it's a group of initiatives, is my point, that we're going to make those books secure. Because you cannot never have a security vulnerability, right? There's always going to be a motivated security researcher, motivated threat actors finding stuff. But you should not wait for a vulnerability to fix it. You should also be ready to lock stuff before a vulnerability is even found, right?
There are also things like Cisco Live Protect, which has a funny name. It has nothing to do with Cisco Live. It has to do with Cisco Live Protect.
It's Live Protect from Cisco.
Live Protect, exactly. Which works on data center switches like NXOS, which will aiming at using eBPF. So that's the thing inside the Linux kernel to apply live fixes to known vulnerabilities. So when something new pops up, it can be deployed live without an upgrade, without a reboot, and just from one click. So those are the type of initiatives that Cisco is also doing on top of resilient infrastructure. It will also help reducing the time it takes to get a vulnerability resolved, actually.
Yeah, because from my experience right now, the problem is you have a vulnerability, then you need to wait for a version that fixes it. It's not always possible. And then some people may be in a previous release train and then say, well, I need to change my train to another major train where there's other stuff changing. So they have limited time to do validation testing and so on. Like, it's really annoying to have to upgrade when you're not ready to.
And that's why those solutions make a lot of sense, because there will still be vulnerability that require a fix. And when a fix needs to be developed, it will always take time from the development perspective, but also from the deployment perspective. So whenever a fix is ready for you as a customer to deploy that, test that in the network. So those solutions that have a live aspect to it, like fixing, blocking a vulnerability before an actual fix is developed, will be necessary for sure.
Are we going to put everything people need to check in the show notes? I think you have a few documents ready.
Yeah, so there are a couple of links and documents, so please go and check those. There is one document two documents that are really important, is the list of feature deprecation and timelines and the list of alternatives. Flag those and get started in planning the replacement of those.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on the Cisco Podcast Network in SoundCloud or your favorite podcasting app. You can also find us on our own channel called Cisco Tech Stories in every podcasting application. We are also on X at Cisco Tech Story without the S, and on Instagram and YouTube at Cisco Tech Stories. Thanks, and see you next month.